Hi, my name is Shannon Henry, and today I'm going to be talking about a math concept called fractals. I know, math isn't everyone's favorite subject, but trust me, fractals are pretty cool, and it's something that's actually relevant to real life. So what is a fractal? Well, when you were younger, you probably learned about a pattern, or a certain shape or design which is repeated over and over again. Well, this essentially is a fractal. Fractals are images or objects that no matter how far you zoom in will always look the same. They make for some pretty cool pictures, but let's look at how this is possible. A true fractal can only exist on a plane. The simplest of fractals are made by repeatedly drawing the same shape over and over again. This gives each fractal a unique property. One example of this is the Coke snowflake, a personal favorite of mine. To make this, start out with an equilateral triangle, and then on each side's middle segment, draw another equilateral triangle, and repeat this process. Okay, so it looks like a snowflake, but who cares? What's interesting is in the fractal's properties. If we take the limit of both shapes' area and perimeter, we find that the Coke snowflake perimeter goes to infinity while its area is finite. How is this possible? Well, we see that each time we're adding a new triangle, we're adding a new line segment, meaning that the perimeter will go on forever. However, each time a new triangle is added, its area is slowly getting smaller, meaning that each new triangle's area is slowly converging to zero. Okay, so these are pretty easy to create and understand, but let's kick it up a notch with the infamous Mandelbrot set. This is created with an actual equation, z is equal to z squared plus c, where c can be any complex number, or a number that includes I. To use this equation, pick any number on a coordinate plane and use it as c, and start by plugging in 0 for z. Take the answer you receive and plug it back into z and repeat this process. After completing this recursion a few times, we can tell whether the number approaches infinity or is bounded. Those numbers which increasingly get bigger the more the equation is used are said to approach infinity. Those numbers which simply repeat over and over, such as with this set, are bounded. Only the numbers which are bounded are actually a part of the Mandelbrot set, and for that reason we color them black. Those which are not are colored based on how fast they approach infinity. This creates a stunning picture which if you zoomed in on forever, you would eventually find the same black circular pattern. Okay, I know what you're thinking. Yeah, you're right, Shannon, these are pretty cool, but how are they relevant in real life? Well, if you've ever seen an animation or played a video game, you've probably seen fractal math at work. Images and scenery that once took months to create now only take days with fractal math, and even though they're not really heard of, fractal antennas are some of the most widely used fractals in the world. They appear in almost every wireless communication device thought of. However, most importantly, fractals allow us to express the biological world in ways we never could before. Just take a look around and I'm sure you'll find a fractal. Look at this fern and piece of cauliflower. Now look at the trees. Their branches separate in the same monotonous pattern each time. This is true of river systems and even your blood vessels. With fractal math, computers can be programmed to see abnormal and harmful manifestations in the human body. Fractals are a fairly new concept, and it's believed that not all of their mysteries have been uncovered. Who knows what will be made possible in the future?